Hello, hello. Good morning, good afternoon, good evening, wherever you are, and welcome to eCHO episode 194. I'm Dan, and
I'm Nico. Hi, everyone.
hey, everyone. So let me just bring in the show notes and we'll kick things off. So, as mentioned, this is episode 194. And we're going to be talking about Tetragon. We've covered Tetragon a number of times. We're going to, for people who are new, we'll step through what Tetragon is before we kind of kick things off. But there's been some exciting new things that we really want to talk about. But before we kind of get into that, we'll just kind of quickly step through the news, and then I know Nico's super excited to kind of get delving into all of this, and I'm wearing my Cisco t-shirt today as well, just out of pure excitement. So yeah, before we kind of kick things off, as part of the show notes, the recent eCHO news that came out recently, episode 89, we have a new advocacy fellowship in the eBPF program. EKS have now extended support for Cilium. The Cilium Con schedule has now all been announced for the upcoming KubeCon in North America in Atlanta in November. And then because there is never enough KubeCons, the CFP is already open for the next KubeCon, which is in Amsterdam, I believe, at the beginning of next year. So if you have any Cilium, eBPF, Tetragon, networking, Kubernetes networking ideas you want help with, or any kind of help getting your CFP submitted, then come find us on the Cilium Slack. Looking forward to seeing you there. So that's the news.
I feel like I'm going to spend half my year in Amsterdam next year with all this, with Cisco Live, with KubeCon. I can't. I need some tips about Amsterdam because I'm not quite warming up to the place yet. I need some. I don't know, something to make it make me excited about going back.
Yeah, it's interesting. Like Amsterdam appears to be kind of like the new Barcelona for conferences. Like I for whatever reason, a couple of years ago, everything was always in Barcelona, and now it's kind of Amsterdam appears to be the place to kind of do these things.
Yeah.
Cool. So that's kind of quick roundup of the news. As mentioned, this episode is largely going to be around Tetragon. So before we kind of delve into it, I suppose we should, for people who are new on the stream, kind of do a bit of a quick overview into what Tetragon is. Would you like to take care of that, Nico? Or?
No, I would like you to take care of that.
Okay.
No, I'm here to ask the dumb questions. You're the one who goes in. Who knows more about it. No, seriously, it's I guess Tetragon can be described in so many different ways, right? It's
100%. Yeah.
We often define it as runtime, security, and observability, right? But what how would you even define runtime? If you're a network engineer, so you're just kind of tuning into this show, is that like an antivirus? Why is it like some kind of what does runtime mean in this context?
100%. Yeah. I mean, I come from a back in the day kind of perspective of having to install agents across the fleet of machines and things like that, where you would have kind of people screaming about the fact that all of these tools would slow down your servers and break things and things like that. So I think it's been a long time coming for a new way of kind of doing this enforcement and protection, where not only do you have the protection, but it's also enforced in a way that doesn't impact workloads and things like that. And I think one of the cool things about Tetragon is that a a lot of the tooling originally was kind of um, reactive. So things would happen and then the tool would spot it.
Hmm.
But at that point, damage may have already been done. Whereas the way that Tetragon kind of sits, it's proactive. It sees things before they actually happen. So it can provide a lot better protection for actually what's happening within a system.
And it can. So we're in the eBPF show, so it's using eBPF. It's like the little sibling to Cilium in many ways. Not doesn't rely on Cilium. It's not dependent on Cilium, but it's built by the same original team. And yeah, like I think part of the reason behind it, the fact it's so efficient, is that it's using eBPF to observe everything which is happening inside the box.
Yeah. Yeah. I mean, it effectively will reprogram the kernel so that behavior simply just can't happen. Like, effectively, it's almost like you've taken the kernel and written hard coded into the kernel that only this behavior should ever actually happen, should ever actually be executed. So, should something actually occur that is out of the rules of that, then it simply can't happen, which is a very cool way of basically meaning we've locked it down by the rules that Tetragon is enforcing.
Yeah, and I think and I'll just bring this page together, which just present this, just bring them to the tab. If you can bring this up,
I
Dan.
certainly can. Shall I add it to the stage? Here we
Yeah,
go.
yeah. I think that's on the Tetragon.io landing page, and it just shows like all the things that Tetragon is able to do, which is to observe all the processes and systems goals and network behaviors in again within the kernel. And what I like about Tetragon when I first started using it is that it had the different contexts, right? From a like a Linux perspective, as a context about I don't know, like binary and process ID and the folders and anything like this, but also from a networking, you can see like the five tuple, like source IP, destination IP, and ports. And then it has some of the more like the Kubernetes context as well. So you can kind of get all this data together and observe really in everything that happens within your host.
100%. Yeah. So, I mean, it provides a number of different ways of kind of latching itself onto a running system. It'll latch into the networking stack. It will latch into system calls. It will latch into function calls that are actually happening in the kernel. It can latch into LSM modules and things like that. So it provides so many different ways of providing enforcement and understanding into what is going through the brains of your operating system. So it's unique in its abilities to kind of get in there and do what it needs to do.
And it's like super efficient. I think that's also the thing that people have observed. I guess maybe because that's the BPF magic, right? That's the
Yeah.
reason
So
it's
unlike an agent that basically is sit there and ingesting absolutely everything and building this big memory model of tracking and this, that, and the other, we've basically got all these tiny little programs that are sat there attached to the kernel, but they're not using any memory or they're not doing anything until they are triggered. So
okay.
until a file is opened and the kernel then tries to execute, the file opens this call, that is when we suddenly spring into life and do things. And that's it. We're not sat there continuously pulling in everything because we don't need to. We're event driven. And that's
Mm-hmm.
that kind of proactive versus reactive kind of difference between having something in user land sat there just ingesting a million things
Yeah.
and then trying to work out what it's seeing at the end of the day.
and then all the kind of these logs and events you can just go and explore. And actually, some other news we can talk about today is if you're interested, we've launched a brand new lab. Came out yesterday, which essentially shows how you can take all the information collected by Tetragon, which is used by our runtime security, and then export it to Splunk, right? Which could be Splunk, could be any other log connector, if you like, or SIEM. So, but if you want to go and try it out, we now have a lab which you can go and get.
Excellent.
On isurveillance.com.
Yeah, because I think that's always kind of a bit of the thing. It's like, right now I have all this information. I need a way of then kind of understanding it and kind of formalizing it and things like that.
And I think that's one of the things we'll start seeing when we look at when we're running Tetragon on a switch, is especially in the way it's been set up in on the Nexus switch, is generating a ton of logs, and manually going through crawling through them is not exactly user friendly. So what you'll want is essentially to just collect them on your device, but then export it to something else for forensics.
So Tetragon on a switch, you say?
Yes. And I was kind of and I mean, just bring this image up. Whoops, I can. Well, I guess just going back a bit, I was in San Diego in June when the president of Cisco announced this Cisco Live Protect. Oh, that sounds good. What is it about? Oh, it's actually using Tetragon. How exciting! And turns out to be essentially running Tetragon on a Cisco device. Now, I appreciate this is not a Cisco live stream, but the idea could be, I mean, if any other vendor decides to go and apply the same thing, I mean, possibly they can just use the open source Tetragon and run this across any devices. You know, you can, and that's what we'll talk about as well in this show, is like we can run Tetragon across vast majority of devices, as long as you get a specific type of Linux kernel. Anyway, so G2 announced this Live Protect, and the idea was, okay, what if we're able to do like virtual patching on your network? And again, conceptually, is if, say, a CV is released tomorrow on your Nexus device, for example, as a former network operator, what I would have had to do is to go and, well, check across all my estate to see what devices are impacted. Then see, hopefully, I'll wait until a version with a fix is ready. Plan the outage, schedule the maintenance window, test the upgrades, have a backup plan, and obviously usually has an impact, when you upgrade your network device, because it has to reboot unless you have some kind of in-service software upgrade on some devices. But so the idea is, okay, what if you could prevent a specific exploit by using something like Tetragon, and then that gives you a bit of time until you have a fix, and maybe you can delay or as part of another kind of maintenance window, and not having to do this every time a CV is released, which can be quite often. And I had this slides a couple of months ago, and then I looked at the Cisco documentation, and it turns out that 10.6.1.f has been released. And let's take a look, and then you go through the release note, and again, being a Cisco device, you've got a lot of new features, some IPv6 stuff, and blah blah blah. And then eventually you get to scroll down and kind of buried. This is support for securing NXOS with Cisco Live Protect. Okay, so now we do have some support. So from 10.6.1, it looks like we have some Tetragon built into the Nexus software. Not all type of Nexus software to begin with, but just super excited to see that this was finally released, and obviously we took some time over the past couple of days to try to play it to play it with.
Yeah, 100%. It's very exciting because I mean, like, I think I don't know, was this the plan all along? But kind of, this feels like the beginning of Tetragon finding itself in kind of more and more places. I think a lot of people just think Tetragon needs to go in my Kubernetes cluster, and it'll just do some Kubernetes runtime enforcement and things like that. And that's kind of simply not the case. You can run Tetragon outside of a Kubernetes cluster. You can run it on a switch. Like, where else? I mean, this is I like being the beginning of Tetragon slowly making its way to a bunch of different places. And I think there was the CrowdStrike issue that kind of came up a while ago, which is another kind of runtime enforcement issue. And Joseph here with the question: when does Tetragon release on Windows? It's a very good question. So in answer to that question, eBPF on Linux has had a much easier path because the Linux kernel is open source, and with the right amount of massaging with your patches, etc., things can get accepted upstream easier. The Linux kernel, the Windows kernel even, is owned by Microsoft. So it's a lot longer path in order to get things like eBPF added to the Windows kernel. That being said, lots more progress has been made, especially in the last 12 months. The CrowdStrike issue, I think, really showed that there is a lot of weakness out there that can be exploited by bad implementations of runtime enforcement. So eBPF with the verifier and its protection and the way that it works has shown its potential in Linux and has basically played its hand in kind of almost forcing Microsoft now to adopt it at a much quicker rate. So whilst we don't have a date, I think it's quite clear to see now if you go to the eBPF for Windows repo on GitHub, you can see all of the action in there. The eBPF for Windows channel on the eBPF Slack as well. There's a lot of things happening in there. There are monthly meetings detailing all of this. So I think as soon as kind of the last remaining hurdles and driver signings that we're waiting on, once that's kind of over the line, I don't see the actual implementation of Tetragon for Windows being the biggest hurdle. I think once eBPF is there, we'll be able to start taking advantage of it right away.
Do you see like a use case for Cilium on Windows?
100%, yeah. I mean, I think, cloud native workloads on Windows, it's the whole containerization on Windows has had a bit of a rough patch to a certain degree. I was at Docker when Docker for Windows kind of first came out, and it was, like your Docker images were like 6 gig or whatever because they had like the full .NET engine and half of Windows NT and things like that. Things have vastly improved these days, and there are a lot more workloads that people want to run on Windows. So, it's not just a case of, and Cilium isn't just networking anymore. It's a case of having network policies, the segmentation, kind of all of the things that people use Cilium for now stretched to Windows. And I think it's a perfect use case for Cilium on Windows.
Okay, good stuff. But I guess that's kind of future looking. We thought we'd just go more like inward looking and before we start talking about the running Tetragon on an NXOS, we wanted to see about also like wacky places where you could be running Tetragon. And I mean, just in general, like I remember watching a video about how eBPF was being used in Android phones almost by default these days for telemetry, for I think IPv6, maybe NAT46, NAT64.
NAT64, yeah.
Yeah, yeah. So um, it looks on paper that if you get the Linux kernel, then you should be able to run some of these programs. Now,
100%.
um, have you had any luck with?
So embarrassingly, I have been completely shut down today. I was quite excited when we originally came up with this idea of things that we were going to do as part of this podcast today. So I was like running around the house trying to work out where Linux is actually running, and it's running all over the place. Unfortunately, I don't have an Android phone anymore, which I did. But as Nico mentioned, Google have made huge investments of having eBPF due to its powers. Do a lot of clever work on Android phones and things like that. But yeah, I mean, there are a lot of Linux appliances that you will find within the house. I have like a bunch of NAS appliances, Raspberry Pis, and things like that. So like I was thinking it would be a great example of showing, in a data center, you have servers, storage, and networking. So servers are already making massive use of eBPF, Tetragon, Cilium,
Mhm.
this, that, and the other. Networking, we're going to talk about in a little bit.
Yeah.
Storage, on the other hand, there's not really been a huge amount of discussion around kind of eBPF on storage appliances. So, kind of what could you do with eBPF on a storage appliance? There's loads of stuff. I mean, instrumentation, huge thing. Being able to work out, kind of why you are getting latency on certain file
Mhm.
systems, things like that. The capability of enforcing who and what can access what files on your storage appliances,
That's
all
true.
of those sorts of things. So there is a huge amount of potential with eBPF on your storage appliances, providing instrumentation, observability, and a number of other things. Sadly, so I had a power cut about a month ago or so, which blew up one of my Synology NAS boxes. So I have a brand new one. I was like, awesome. I'm going to install Tetragon on here, and I'll use it to basically monitor filing events and things like that. This is where it all kind of falls down, because for whatever reason, Synology use a kernel that's over 10 years old, even on a
Ah,
brand new storage appliance. So simply put, I just could not get eBPF to work on a kernel that old. And why a brand new appliance comes with a 10-year-old kernel, I have no idea. That was very disappointing.
but
Um,
I think it goes to show that we still have a long way to go, right? And um, I think especially I guess vendors of connected things won't take
100%.
it, won't be taking any risks running the Linux. They just don't need to. But um, I guess we can see maybe in 5, 10 years time. Well, what kernel do we need at these days? Like, is it 4 point something or 5 points to be able to support most of the eBPF capabilities?
Yeah. Yeah. So, I mean, off the bat, basically, um, for doing most of the kind of cool stuff, we basically need a 5.4 kernel, which is quite old. I think we have a quick look. So 5.4 it's 5 years and 9 months ago that kernel came out. So it's older than my child. It's quite an old kernel. But that and one other thing, which is a function in the kernel, which is called BTF, which stands for BPF type format.
Okay.
And that effectively allows eBPF programs to run anywhere. So, we always have this conversation on kind of kernel modules were really powerful, really kind of cool way of extending a kernel, but they were tied intrinsically to the version of the kernel you compiled them against. And you know that was the big issue, that if you were a driver manufacturer, and you wanted to give out new drivers in the form of kernel modules, your life never ended because every time there was a new kernel that came out, you needed to create a new version of that kernel module and ship it and things like that.
Okay.
So, kind of one of the strengths of eBPF is the capability of not having that one-to-one intrinsic link between kernel versions and your eBPF assets, your programs. So 5.4 comes with a lot of eBPF functionality, so a lot of more cool stuff you can do with eBPF.
Mhm.
But the BTF functionality in the kernel is what allows you to not need specific versions of the kernel. As long as that's enabled in the kernel, then backwards and
Okay.
forwards compatibility exists. That's what you need.
Okay, and that's what you didn't have in your NAS, and it looks like you had a similar experience with
Yes.
your Pi.
So, my brand new NAS came with a kernel that was far too old. It was 4.4, which, as I've mentioned, is over 10 years old. So there's no way I'm recompiling a kernel for my storage appliance because I don't want to lose all my content and things like that and this, that, and the other. Raspberry Pis are everywhere. They come with a relatively modern kernel, 5.15 or something or other, that you can get out of the box. But for whatever reason, in their wisdom, the Raspberry Pi kernel developers have disabled the BTF functionality in the
Ah,
kernel.
okay.
So it's not going to happen right now, but yeah, so it's still going on in the background. In the background, actually, on this Raspberry
Oh,
Pi right here, it was quite warm because it's compiling a new kernel for itself with BTF enable. So once that,
and again, and again, for the people who just don't, are not coming from that kind of Linux background, like what does recompiling the kernel involve?
so I mean, it's not a lot really. It's quite a daunting task. It's not something that I would want everybody to do on a daily basis. Um, but effectively, you have all of the source code for the kernel, and then you have a single config file. That config file is basically filled with enable this function equals y or n. So
Okay,
it's a case of turning your n into a y
okay,
and then running the make command, and it will build you a brand new kernel. But the kernel is millions of lines of C code, and it takes quite a while, especially on a very
yeah,
underpowered Raspberry Pi. But I think this sounds scary than it is. I think the point is that most generic kernels these days that are 6 years old, just about 6 years old, by default come with all of the functionality that we actually need. Um, it's just a case of some appliances, for whatever reason, won't go to modern kernels at the moment until they're ready to, or they have made a decision to tweak the default kernel settings and disable things that potentially didn't need disabling.
okay. So I'm guessing so. This Tetragon on NXOS, which we're going to go and see now, that could work across other either type of Cisco devices or any other kind of network devices, right? It's or firewalls or as long as they are modern enough and obviously have the BTF.
100%, yeah. So, um, as mentioned, yeah, as long as you meet those simple requirements of a relatively 6-year-ish kernel with the default functionality enabled, then your program will just run. And yeah, I mean, so I did like a bunch of Nexus stuff maybe a decade ago or so, and um, back then it was kind of quite clear that like the control plane was Linux and the data plane was their unique silicon and things like that. Um, and a lot of the hardware manufacturers for other data center assets have kind of followed the same footprint. Other switch manufacturers as well. Um, I'm pretty confident in saying I think Arista or Aruba or whatever it is either use LXC or Docker as part of their control plane, and then the which then configures their unique silicon side of things and things like that. So um, many moons ago, Nexus used to use LXC, which was pre-Docker for having workloads isolated on a Linux control plane, and that used to have the Nexus software running in it, and then it would configure your 10 gig interfaces and all that sort of jazz. And now it's all changed and it's all modern. But yeah, as mentioned, it's Linux. It's running a recent-ish kernel. Tetragon could just run on there.
Okay, should we go and take a look then? Can we? So I know you got. I'm connected right now to your Nexus switch, which is running in your home. But can we show
As you
people
do.
how to? Yeah, can we build one from scratch and?
So we can. It's quite a slow process. So I'll quickly kind of walk you through the. It's very straightforward. He says, but I'll just kind of quickly. Let me just see here. Bear with me 1 second. Sorry.
Yeah. So one thing you didn't happen to have a Nexus 9300, which I imagine cost quite a few pennies. Not something you would be running in your home lab,
No.
but you get hold of the virtual version.
Yeah. So I'll bring my screen in and I'll just kind of quickly walk you through. It's quite a simplistic thing to do. So here we have. You'll have to ignore some of my vCenter naming.
With your cheeky Kubernetes.
I probably had a Nando's that day whilst I was deploying Kubernetes or something. But yeah, so it comes as an OVF. You will select that OVF here. And then effectively you will kind of walk through the steps of deploying it as expected. So Nexus 9KV.
And I think that OVF you can download it from the software.cisco.com if you have a
That's
Cisco
correct. Yeah.
account and try it out for yourself. But yeah, so you're deploying a virtual machine running Nexus 9000.
Yes, that's correct. Yeah. So as you do, you would basically select where you want it to go. This is kind of the most important thing. I don't know if you can see here, but effectively defining how it will look within your environment. So I have a couple of different networks with VLANs and stuff like that, so I can do separate networks for different use cases. One of them's for like bare metal provisioning and things like that. But effectively, the management interface on the switch is the one that you will need to connect to directly. So that will need to go on my lab VM. So that's my default network that I can access from this network. And then all of these other networks can go on either my physical network or the deployment network, which is a separate network and things like that. And then blah, 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 blah. Once you do that, click finish and it will deploy. I'm not going to deploy it again because I've already done it a number of times. But there's a couple of things to be aware of with when doing this, and I'll quickly show you what those are. So in order to use the NX Secure, so the Cisco Live, it's got many names. So Cisco Live Protect isn't called Live Protect inside the switch features, it's called NX Secure. Don't know, marketing.
Yeah.
But so what you'll need to do in order to do that is it will require 24 gigabytes of RAM on the switch. You can see that in the release notes as well, but 24 gig is required. Otherwise, when you try and do the feature NX Secure, it simply won't work. It will just tell you, it says this feature is not available on this switch. It doesn't complain about the memory or anything like that. It just says it's not available.
Okay. Very useful error message. Thanks.
Yes. And then the other thing is when you are configuring a switch for the first time, a switch doesn't come with a monitor. It's you need a way of connecting to it. So typically, if you ever worked in a data center, you will have a blue cable, and that blue cable is RJ45 to serial, and it's the default for Nexus switches. We don't need that on a virtual appliance. What we will do is the serial port we will do over the network. And basically what we do is, this is a VMware specific thing, but we will expose the serial of the VM over telnet on port 12345. And this port is exposed on the node where the VM is actually running.
Got it. So that's for the initial configuration.
Correct, yeah. So you can't do any configuration on the console of it. You can just see that it's booted up. Like,
yeah,
nothing actually works. You need to go onto the serial interface. And basically the serial interface will, first time set up, go, do you want to configure the management interface? You will say yes. Give it an address on your local network. Give it an admin password. The admin's the default user. So you give your admin user its password, enable SSH, and then the switch will reboot. And it's then on the network. You don't need the serial interface anymore. You can SSH to it and do what you need to do. So the initial setup of a Nexus switch is pretty straightforward. There's not a lot to just putting it on the network. Once it's on the network, it's time to actually do the real work.
Yes. And this, I mean, I'm currently connected to that Nexus you were just showing. I don't know if you want me to to
Feel
log
free,
on. Yeah. Let's go and do that.
I suppose one of the benefits of a virtual Nexus switch over a real Nexus switch, I worked in data centers quite a while ago. It's been a while now, but they are so loud, the physical ones. The fans in a Cisco Nexus switch will deafen you if you are near them for too long. Virtual one is silent. Fantastic.
Here you go. So I've brought up my screen.
Bring you in.
And this is I can't remember anything about my Cisco days. I have a CCIE expired. I can't remember how to clear the freaking terminal. Clear terminal, maybe.
I have no idea either.
No. Anyway, it's so embarrassing.
CCIE back.
Yeah. What I can remember from my days is if you're on the Cisco switch and you're run show run, it shows the show running configuration. What we can see is obviously we're running that 10.6.1 version, which is the one that supports Live Protect, and you can see we have enabled the NX Secure capability, which is again Tetragon on NXOS. We've also enabled Bash shell feature, which enables you to enter the shell of your Nexus, the Unix shell of your Nexus device. And then you get kind of all virtual interfaces. And that was kind of the only thing we had to do to enable Tetragon to run on the Nexus device was to enable feature and execute. Right? So that was just one thing, and there's nothing to it. Now, what we can then see is going to the Linux shell. Now, the first thing I think which is interesting is looking, okay, what is the Linux? Let's see if I can zoom in as well.
That's a bit better.
What is the kernel actually running on this Nexus device, which is 5.10, which is a bit more recent. Well, that's a bit better. That's how would it be, like 4 or 5 years old? But so that has the support for BP, all the BPF tools that we need. And then I guess the first comment we wanted to run was this one, right? So we got a container, and I imagine that as soon as we run enable the feature, I guess a slim version of Tetragon was deployed on the switch, right?
Yeah, so it's quite. If you run configure space terminal and then do feature NXOS, that enables the not NXOS, NX secure. And it does two things actually. First, it enables Docker because Docker is not enabled by default. And then once Docker is enabled, it will then bring up the NX secure, which is actually Tetragon.
I think it's super interesting because in a way that opens up. I just don't know if Cisco has used this before in terms of running lots of containers inside its software for particular types of services. Do you know what I mean? Like, so they kind of decided, okay, we are going to make the most of having a kernel and having support for Docker, and we can then do things like running Tetragon. But I just feel like it just opens up, potentially many more use cases.
100%. I mean, feature ILB just comes
Yeah,
up.
yeah, yeah.
Yeah, there you go.
So yeah, that many more things can be added on. And then actually there was NX secure. Now we can see things like you can either see NX secure log files. Actually, before we do that, let's do a show NX secure status. Now, yeah, the first time I see the word Tetragon on a Cisco on a Cisco CLI, right? So that's
Yep.
again, it's running. We now have a Tetragon agent running on a Nexus device, and all these log files now. They are essentially events captured by Tetragon, right?
Yeah. So I think it's worth mentioning at the moment in this release of NXOS, Tetragon is there. Oh, sorry, Live Protect is there, powered by Tetragon. It's there doing its thing, but it's basically not enforcing anything at this point. It is purely there capturing absolutely everything that's happening all around kind of the operational nature of the switch at this point.
Yeah, and I think that's and I'll just share the configuration because this one here, if you can bring it back up down on the screen.
Yep.
This is again the Cisco Nexus Live Protect configuration guide. So what it tells us is security features that protect the control plane of the Cisco network devices. And NX Secure uses a technology called Extended Berkeley Packet Filter eBPF to try, detect, and report security events in real time. I think that's maybe one of the first occurrences of the word eBPF in the Cisco docs, and I'm sure there'll be many more to come. But
Yep.
yeah, as it stands, it's only in monitoring mode, and as you saw in the roadmap I was showing before, eventually there will be some enforcement happening. But yeah, it's it's detecting and generating log files from each anomaly event. What I was trying to do while you were failing to install Tetragon on multiple devices, I was failing to do something which was to export the event logs using the telemetry feature. So on NXOS, you have the ability to collect a ton of data. It's not just the one collected from Tetragon. And they have these telemetry features which they can then go and export the data to an SIEM or anything that would happily receive JSON files. What I was trying is I enable Splunk Cloud, again, trying to stay in the Cisco family, and I was trying to export it. I just ran out of time, and but potentially what you can do is you can just enable that feature and then export all the events that are happening on the switch to a third-party system. And and just to make it super clear, this is not about improving security and observability of what's happening of the network flow crossing the device, right? This is about the network devices themselves. It's about improving the visibility of whoever is accessing your network devices and understanding what they're doing and hopefully preventing anyone from malicious doing anything malicious.
Mm-hmm.
So I failed in setting up the telemetry and exporting all the logs, but and I will go back to Splunk to the VS Code.
Yeah, I suppose one of the things it doesn't tell you on there is it's got all the steps for kind of configuring telemetry, but telemetry is not turned on by default. So you need to do feature telemetry before you can actually do any of the telemetry commands. I think there's
and then you need to work out the confusing docs. And even surprisingly, I've not found any references between showing how to export logs from a Cisco device into Splunk, even though now Splunk is part of Cisco. Anyway,
it's all bleeding edge stuff that we're kind of covering today. So there's, I guess, there's still a few rough edges, as it were.
Absolutely. So there were just a couple of more things I wanted to show from here. Well, I guess one is these logs. You can see. You go back to the folder. There's even a README if you go and look. Bear with me.
I need to go back to the shell, I guess.
Yes. I'm on the shell. It was here. Go. I don't know. Yes, so it's Sue. Where's it here? Sorry. This. Right. There's even a README you can find inside the
Switch itself.
Switch itself. It explains how it's set up. Again, this is early days, right? That feature came out about 3 weeks ago, and there's an internal README for people who are curious. So what we are doing, what Tetragon is doing as part of NX Secure on the next OS to begin with is just to monitor everything happening. Every process that the admin is running, every privileged process execution. So I guess what would that mean from your perspective?
That is anything. Well, I mean, so what you did in terms of getting shell access, you went from the admin user and did bash with sudo su. So that is super user do, super user. You have basically done privilege escalation from admin to root. So that will have been tracked and that will be in one of those logs.
Cool. So we're tracking a lot of the things, and then what you will see again in these log files is we are just the log files keep being appended with the latest event. So I just took some very just a couple of the samples before. Even when I decide to open the Tetragon logs using the cat, that will be reported by Tetragon. So just looking at the logs created by Tetragon will be like, oh, hang on, somebody is opening that file. So what we can see, and this, what Tetragon generates is, again, a ton of data, which is typically in JSON format. And you can see just a lot of things about what was done. So the process idea, the actual binary executed, the arguments. So, this is a binary, this is application, and this is the argument of the application. And then the Linux capabilities. It's just like for every single thing, and you can even see the parent process. So I guess I was in Bash.
Yep.
And ancestors. I mean, I don't even know what would an ancestor mean in that context.
So this is effectively in your process. There's a thing called, well, I don't know if it'll be available. It's called PS tree, but effectively, you have the legacy of processes. So it effectively parent, child of that is that kind of steps all the way back to your grandchild process or your great grandchild process. So you did a sudo su, started bash. So sudo su was the first process, bash being the second, cat being the third. So it's basically done a walk backwards to give you the full list of the full hierarchy of who's been doing what.
Awesome. Okay, so it does show me that kind of privileged execution. Of I was able to go from just being a regular user to being a super admin.
Mm-hmm. Yeah, I mean, like the entire control plane here is being monitored for absolutely everything that occurs in here. So, like, forensic understanding of why something happened on that switch. Tetragon is basically aware of everything that's happening and has basically captured the full set of steps that it took for somebody to get there.
I think for a network admin, and I need to think about it but I wonder if it can really show me who made changes and being able to relate to, okay, that person was, and I guess there are also ways to do that, right? Because you can maybe look into the logs and maybe into, the server when you authenticate it to the switch. But what I mean is like, it also gives you a different perspective of, okay, that change was made on my network device, but who logged in and what was the actual commands, just provides probably more insight into the user session than you would typically get.
Yeah. So, I mean, you can see here that we can work out. So imagine you had like 20, 30 network admins. They all had their own unique logins to the switch. Could well be that they have proper Active Directory, LDAP, whatever. But effectively, all of that information would be captured here. We can see, for instance, we could use current working directory, so CWD. We know that it was the admin user that you came from that executed sudo. So, that would have been nvbear who would have logged in and sudo su'd, and then we'd have seen the tree of you deleting some VLANs and doing some nefarious things, and we'd have known it was you who did it, basically.
Yeah. And I think that's going to the future use cases with the enforcement is, okay, now I'm able to not only see what the actions were taken, but then I'm able to go and prevent a particular CVE from being exploited, because I know that this CVE is when somebody is running this particular binary or application. And I can say, okay, I will stop this particular CVE from happening by blocking this very specific action and nothing else, right? I'm just preventing the trigger point.
100%, yeah. I mean, like a lot of the CVEs or things like buffer overflows and things like that. So we would have eBPF code done by Tetragon, which would basically say, if this large string is ever sent to this library, then just we can basically block those sorts of things from happening. To fix those, you're talking about operating system patches and bringing the switch down to make fundamental changes to the operating system. Where Tetragon is basically just changing a tiny bit of the kernel through eBPF, so like stuff just can't happen.
Yeah, surgical procedure with
surgical precision. Yeah.
So yeah, I mean, there was quite a few other logs that I saw as I was looking around, but I think now our audience can see some of the things that can be done and some of the action that can be seen. And again, what you might have more success than me in setting up export of the logs to like Elastic or the third party systems, which you can then filter. Um,
Mhm.
but yeah, it's just collecting a ton of data, which wouldn't have been available to like a network operations team in the past, or SecOps teams.
100%. And as the README says, phase one, like there's nothing actually stopping us today actually putting our own policies on this switch. It's like I've not done it yet because I didn't want to break anything for this demo, but like we could probably start looking at doing things on at least this demo switch today. But phase one is largely getting it into people's hands and letting them learn what's kind of happening on their switches. They can use that information to build patterns and this, that, and the other, and work out what it is that they don't want to allow on their switches and things like that. Phase two, yeah, I'm super excited. Do we start moving into the network a little bit more and kind of saying what can and can't happen there? Do we? Because as I say, we can hook into all manner of different places within the running switch.
Yeah, right. So that's just again, that was a sneak peek into something that came out, which I posted about it on LinkedIn a couple of days ago. I had lots of interest, and we thought, might as well just go and make it the topic of this week's eCHO show. I There was any other comments or questions in the chat? Anything else we
Well,
want to?
I mean, there's a bit of a big ask here, but this is probably more for yourself and Raphael.
Yeah. I think Joseph, no, we'd love to do that. Yeah, it's on to do list. How we make this happen, I don't know. If we yeah, leave it with
Well,
us. Leave it
well,
with
yeah,
Raphael.
we'll work it out.
Yeah.
But yeah, I think it's fantastic. It's as I say, we Tetragon on servers, eBPF on servers has made perfect sense for a while now. Like Cilium being kind of the cheerleader, as you will, for kind of having really cool functionality powered by eBPF. Tetragon now basically becoming one of the de facto standards for observability and runtime enforcement. The fact that that is now moving its way from servers onto physical network devices. And yeah, I mean, I think there's a lot more area. I would have loved to have had it running on a storage appliance. So if anybody from NetApp or blah 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 sees this video later down the line and wants to send me an appliance, I'm all ears. But yeah, and where next? I mean, it's already running on smartphones. I don't see why over time it couldn't be almost the de facto for runtime enforcement on phones, on smart TVs, your fridge, your
Yeah.
wherever you're running your devices, and it's protected from CVEs. It's kind of protecting you. It's improving efficiencies and all of those sorts of things. So I think, yeah, this is the beginning. This is phase one of Tetragon moving into more and more places.
Awesome. Right. Lovely conclusion. Well, thanks for having me, Dan, I guess.
No, thank you for having me, John. Cool.
And thanks everyone for joining.
All right. Yeah, thank you very much. This has been episode 194. See you all next time. Thank you, everyone. And
All
thank
right.
you, Nico.
Yeah. See you soon, guys.